It's the last video of Stoic. Limiting and excess reactants. This is new vocabulary. You have to know what these words mean. Luckily, they kind of make sense just from like the words. The limiting reactant is the reactant that is used up completely. This blank is probably not big enough. Sorry, used up completely. And it tells you the maximum amount of product that can be made. The excess reactant is the reactant that is not used up. There is always some of this reactant left over. So limiting reactant limits how much stuff you can make. Excess reactant, that word excess means like extra, right? There's some left over. There's going to be some left over. So if you're thinking about grilled cheese sandwiches, your limiting reactant is going to be the stuff you run out of that limits how many sandwiches you can make. So let's say I have like 30 pieces of cheese, but only 6 slices of bread. I can make a whole bunch of sandwiches with 30 slices of cheese. But if I only have 6 slices of bread, then I'm only making 3 sandwiches. That's it. And then I'm done. Then I just have cheese. I don't have cheese sandwiches after that. I just have cheese. 6 slices of bread can only make me 3 sandwiches. That's it. You just have extra cheese. So your limiting reactant would be those 6 slices of bread that limits how many sandwiches you can make. It doesn't matter that you have enough cheese to make a whole bunch of sandwiches. You just have a whole bunch of extra cheese because once you run out of bread, you're done making sandwiches, like period. And that's the basic idea here. So how do you know if a problem is a limiting reactant problem? You're going to be given an amount for each reactant. So that's going to make it a limiting problem. So if you have 2 givens and they are both reactants, then this is going to be a limiting or excess problem. We previously saw 2 givens where it was 1, I'm going to abbreviate, don't freak out, 1 reactant and 1 product. That was a % yield problem. But if you have 2 givens where they are both reactants, then that's what we're going to call, again, I'm going to abbreviate, don't freak out, a limiting and excess reactant problem. So just, you have to look at what the givens are. And there are some steps to solving a limiting problem. First of all, start with the moles they gave you of the first reactant, and you're going to find moles of the desired product. So that's a mole bridge. You're going to have given moles of the first reactant and go into the unknown for moles of a desired product. So you're going to, it'll be like X plus Y yields Z, and you'll do a little mole bridge from X over to Z. Then you're going to start over with the moles they gave you of the second reactant and find moles of the desired product. So this time it'll be like X plus Y yields Z, and you'll do a mole bridge into the unknown, but this time from Y, like reactant number 2 to Z, to whatever your product is. You're going to look at your 2 answers of moles of product. One of them is going to be a larger number of moles, and you're going to cross it out. Basically, you're going to X out the excess. This is my little memory trick for you. X out the excess. X out the excess. The one that's extra, it's too much. You're never going to actually make that much. You may have 30 pieces of cheese, but you can only make 3 sandwiches. So you're not actually making 30 pieces of cheese worth of sandwiches. You just can't. You just X that out. That's your excess. The moles of product that was a smaller number is the actual amount of product formed, and you're going to box that number as part of your answer if you're handwriting this, which you're not really handwriting it mostly because you're going to do it in Schoology, but it's fine. The limiting reactant is the reactant, the given, that you started with to get your actual amount of product formed. The limiting reactant is going to get used up first. That's your bread. You ran out of bread. That's your limiting reactant. It's the stuff that you ran out of, and it's going to be your smaller answer. The excess reactant, well, it will be from your smaller answer. I'll show you in a second. The excess reactant is your given that you started with. That's going to get you a total number of moles of product that you crossed out. It's the one that you have left over, and it's going to be from the bigger answer that you find. You're going to know which reactant is limiting because the limiting reactant makes less product. Go figure. You're going to know which reactant is excess because that reactant could make more product, but there's not enough of the limiting present to actually make that much product. You could make more sandwiches with all of that cheese, except you'll never be able to because you ran out of bread. That's just the way it goes. So we're going to try a problem together. Look in this problem, 4.7 moles of carbon reacts with 4.7 moles of oxygen to produce carbon monoxide. You've got 4.7 moles of carbon is one given. 4.7 moles of oxygen is another given. And if you look in this like reaction they gave us, 2 carbon plus O2 yields 2 CO, you've got carbon and oxygen are both reactants. So since we were given 2 reactants, that tells us this is a limiting and excess problem. So the steps we're going to follow, the first thing we're going to do is follow a mole bridge from our first reactant over to the product. So that means our given 4.7 moles of carbon. Luckily, this is just finding moles. So we only need one fraction here. We're given moles, we're finding moles. That's only one fraction. Remember to do all your like steps you do every time, right? Start with your given, draw your fraction. What goes up must come down. So moles of carbon will go on bottom of that fraction. And then your unknown should go on top. Remember the fractions for your mole bridge, whoops, should always have moles of given on bottom. Why is my pen like, sorry. Moles of given on bottom into the unknown, moles on top. Moles of your unknown always go on top. So moles of given on bottom, moles of unknown on top. Your moles of your given were the moles of the carbon, and then on top, your moles of CO, the product is what our unknown is. We always got to find the product for a limiting problem. It even says calculate the moles of product here, and there's only one product, it's carbon monoxide. For that mole bridge, your coefficients in the reaction are the numbers you're going to put in there. So the reaction says 2 carbon, that's 2 moles of carbon. The reaction says 2 CO, that's 2 moles of CO. So 4.7 times 2 over 2, that's just 4.7 moles carbon monoxide. Okay, that is one step like that you have done. You still have to do that again with your other given. So they also gave us 4.7 moles of oxygen, O2 in this reaction, and we're going to have to do a different mole bridge into the unknown from that given. So we're going to do another one-step problem of moles to moles, starting with the other given. This time 4.7 moles of oxygen is our given. You're still going to do what goes up must come down. You're still going to put your unknown on top, which is moles of CO again. You're going to use the coefficients from the reaction again. So if the reaction says 2 CO or 2 moles of CO, there's no number in front of oxygen, which means it's really just a one mole of oxygen in your reaction. So 4.7 times 2 divided by 1 is, I'm doing this in my head and now I'm like nervous that I'm doing it wrong in my head. Is that 9.4? No, I was right. That's fine. I got it. Okay. 9.4 moles of CO. Okay. We have done the first like set of stuff. We've done all the math parts. Now we have to make some decisions. So if we go back and look at the like steps to solving these problems, we did start with the moles they gave us. So the first reactant, find moles of the desired product, check, we did that. Start with the moles of the second reactant, find moles of the desired product, again, check, we did that. Now we got to decide some stuff. Look at your 2 answers. Which one is the larger number? You cross out. The one that's the smaller number, you box as your actual answer. So larger number, we X out the excess, 9.4, that's too big. 4.7, our smaller answer, that's the one we're going to box as our actual answer. Basically, what's happening here is what we've calculated is that if I start with 4.7 moles of carbon, then I have enough carbon to make 4.7 moles of carbon monoxide. If I start with 4.7 moles of oxygen, whoops, I meant to make that a different color. If I start with 4.7 moles of oxygen, that's enough to make 9.4 moles of carbon monoxide. Here's the problem. I only have enough carbon to make 4.7 moles. I don't have enough carbon to make 9.4 moles. I only have enough bread to make 3 sandwiches. It doesn't matter that I have all of that cheese. If I only have enough bread for 3 sandwiches, I'm only making 3 sandwiches, okay? I don't have enough carbon to make 9.4 moles of CO. I just don't have enough carbon for that, which means I am not going to make 9.4 moles of CO because I literally cannot. So instead, what I'm finding is that I can only make 4.7 moles of carbon monoxide because that's when I run out of carbon. So the amount that I can actually make is this 4.7 moles of carbon monoxide. I don't have enough stuff to make 9.4 moles. I get to 4.7 and then I run out of carbon and I cannot make anything else after that. I will never be able to make 9.4 moles of carbon monoxide. It doesn't matter that I have enough oxygen to do that because I run out of carbon and then I'm done reacting. It's over at that point. So our next step, once we've X'd out the excess and boxed the amount made, the limiting reactant is the reactant, the given that we started with to get that actual amount of product formed. So this is how much stuff, this 4.7 moles of CO, that's how much stuff I'm actually making. The limiting reactant is the reactant that I started with to get that number. So like I always see students who will say, okay, my answer was 4.7 moles of CO, so my limiting reactant is CO. And then they go, I X'd out the excess, I X'd out CO, so my excess reactant is CO. There's 2 problems with that. First of all, you can't have the same thing be both your limiting and your excess. That's not how words work. Second of all, CO is not a reactant. CO was a product in this problem. It was on the product side. So we need to make sure what goes in this blank is actually a reactant. We only had 2 reactants in this problem, carbon and oxygen. So our 2 answers that go in these limiting and excess blanks have to be reactants. It's got to be one of them has to be carbon and one of them has to be oxygen because they both need to be reactants, and those are our only 2 reactants. So what you do is you look at this number you boxed, that is how much you're actually going to make, and then you just kind of like go backward and go look at what you started with to get that. So to get this amount that is how much we're actually making, I go back and look at the reactant I started with. The carbon is what I started with to get this 4.7. The carbon is the limiting reactant. Then to figure out the excess, remember our memory trick, you X out the excess, but don't put CO because CO is a product. It's not a reactant. The reactant in excess, go look at what you started with. We X'd out 9.4. What did we start with to get 9.4? We started with O2. And how do you know which reactant is limiting? Well, there's 2 ways you could say this. You could say carbon makes less product, or you could say product, you could say carbon makes less CO, or you could say that the reaction runs out of carbon. Either of those are equal answers. That's fine. You just pick which one makes more sense to you. And that's it. That's a limiting and excess problem. We're done with Stoich.